Lesson 9. 8th graders, I am terribly sorry to tell you all this, but we got a lot of work to do. You guys are a bit behind the other groups, so we've got a bunch of lessons to do this week. So first things first, let's put our names on our papers, so that way when they get turned in, I know who to give credit for them. Even if they get removed from the rest of your stuff. That being said, 8th graders, I'm not going to make you guys do as much work as the 6th graders on their packet. They have to do everything, or the 7th graders who have to do all of the evens or odds on their work. You guys are doing your lessons, and you're doing your direct quotes, or you're doing your guided work, and you're doing your independent practice. But other than that, I'm not making you guys do everything. So you guys can thank me later, or I guess I can just pause and wait until I hear the groans from you guys learning that you have to do 3 different lessons in 1 week. I think I hear them. Okay, moving on. We are moving into estimated roots. These are a lesson that is following our last lesson on finding square roots and cube roots. And we don't have any new vocabulary for this one, so that's good. First off, real world link. Gravity. Legend states that while sitting in his garden one day, Sir Isaac Newton was struck on the head by an apple. Suppose the apple was 25 feet above his head. Use the following steps to find how long it took the apple to fall. What is the square root of 25? Well, we know that 25 can be made up of 5 times 5. Since anything times itself that gives you back a number is that number's square root. 5 times itself gives you back 25. We know that 5 is the square root of 25. The formula t equals the square root of height divided by 4 can be used to find the time in seconds it will take an object to fall from a certain height, h, in feet. How long did the apple fall? So we have the square root. If we put in our h, so h equals 25, and we are solving for t. So we put in t equals the square root of 25, because we're replacing h with 25, and then we're dividing that by 4. Well, if we multiply both sides by 4, we can cancel these 4's out, and we have 4t equals the square root of 25. Now, we take our square root. 4t equals 5. And that is our principal square root. And then t, so now we want to get t alone, so we take the 4 and move it back over. T equals 5/4. So how long was the apple falling? The apple was falling for 5/4 of a second. So how long did the apple fall? It fell for 5/4 of a second. Suppose another apple was 13 feet above the ground. Use the formula to write an equation to represent the time it would take the apple to fall to the ground. So we already have our formula. T equals the square root of h divided by 4. And this time our h equals 13. So we set it up. We have t equals the square root of 13 divided by 4. put it up over here. Now, can we find a square root of um, 13 so that we can remove that radical sign? No. The square root of 13 is hard to figure out. Why is the square root of 13 hard to figure out? Well, because 13 is a prime number. But lots of numbers that aren't prime numbers also have hard square roots to find. So when we can't find the square root, we estimate. Estimating square and cube roots. You know that the square root of 8 is not a whole number because a is not a perfect square. The number on line shows that the square root of 8 is between 2 and 3. Since 8 is closer to 9 than 4, the best whole number estimate for 8 is 3. So we know that 3 times 3 is 9, and we know that 2 times 2 is 4. So we know that somewhere between 2 and 3 is the square root of 8. It goes somewhere in here. And we can tell since 2 times 2 is 4, and 3 times 3 is 9, and 8 is closer to 9 than it is to 4, that it's going to be somewhere over here. It's going to be somewhere closer to 3 than 2. Let's move on to our examples. Oh shoot, I am going to be called away from this in a couple of minutes because I have to go do my PLC. So hopefully this won't disrupt things too much. Estimate the square root of 83 to the nearest integer. So we have square root of 83. We need to figure out which one it's going to be closest to. So what is the closest one that's below it? Well, we've got square root, or 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81. So we have 9 squared equals 81. That's not 83, so we know that it's going to be on this side. It's going to be bigger. So we know that bigger, teeth, alligator, nom nom nom. It's going to be bigger than 81. And 10 times squared equals 100. That's over here. So that we know. So we know that 10 squared is bigger than 83. So we know that it's somewhere between 9 and 10. And since 83 is closer to 81 than it is to 100, we know that 9 is closer. So the closest one is 9. It's going to be 9 and a little bit. We know it's going to be 9 and a little bit more. So, which is, but it's going to be closer to 9 than it will be 10. It'd be 10 minus a lot. Example 2. Estimate the third root of the cube root of 320 to the nearest integer? Well, if we put in to our calculator, you know, 5 times 5 times 5, that's 25 times 5, that is 125. If we put in 6 times 6 times 6, that's 36 times 6, which is 200 and something or another. And 7 times 7 times 7 is basically 7 times 50. 7 times 50 is 350. So 7 times 49 is going to be like 7 less than that, 343 or so. So 320 is going to be pretty close to 7 to the third power, but it's going to be less because 320 is less than 340 whatever 7 times 7 times 7 is. So it's going to be, but we know it's going to be between, we're going to have 6 to the third, and we know that it is third root of 3 to the 320th. We know that it's going to be bigger than 6 squared, because 6 squared is 6 times 36, which is basically 6 times 4, which is 240. So yeah, basically we know it's going to be bigger than 6 squared, because 6 squared is around 240, a little bit less than that. And we know that it is less than 7 squared, or 7 to the 7 cubed, because 7 cubed is going to be 240 something, and this is 340 something, and this is 320. But it's going to be closer. It's going to be closer to 7 than it is to 6. So it will be close to 7. You know, it's 7 and a little bit less. Next. A. So we're going to estimate the square root of 35. Well, square root of 5 is 25. Square root of 6 is 36. So we know it's going to be somewhere between those, and we know it's going to be closer to 6. So 5 squared is 25. Square root of 35. And then we have 6 squared equals 36. So square root of 35 is going to be closer to this one. So what is it? It's 6. We're guessing. And we don't know exactly what it is, but it's going to be closer to 6 than it is to 5. Number B. Number B asks the square root of 170 estimated. So 12 squared is 144. And 13 squared is a number that I don't know, but I can quickly calculate on my calculator. $169. So this is 12 squared. This is 13 squared. 169. Well, so it is bigger. This is bigger than this one. It's bigger than this one. 14 squared. I, again, don't know, but I can quickly use my calculator. 196. So, square root of 170 is between these two. And it is much closer to 13 squared. So, we'll estimate it at 13. C. Square root of 44.8. Well, 6 squared is 36. And this is bigger than that. And 7 squared is, times 7 is 49. So it is smaller than that. It goes between those two. Which one is it closer to? It's closer to 7. So 7. D. The cube root of 62. And what times what times what? So we have a cube root of 3 times 3 times 3 is 27. 4 times 4 times 4 is 64, I believe. I can quickly check that in my calculator. So it is bigger than 27. It is smaller than, which is 3 times 3 times 3, or 3 cubed. And it is smaller than 64, which is 4 to the third. So we will use 4, because it is closer to 4. E, the cube root of 25. Well, the cube root of 2 is 8. That's 2 to the third. And it's bigger than 8. And the cube root of 3 is 27. And it is smaller than 27. But it's closer to 27 than it is to 8. And this is 3 to the third. So we'll use 3. And F. The cube root of 129.6. Well, 5 times 5 times 5 is 125. So 5 cubed is 125. And it's bigger than that. And 6 cubed, I don't know. But it is a easy enough number to calculate with my calculator. 216. So we know it's between 5 and 6, and it's closer to 5. So 5 is what we use. Wyatt wants to, or next example, number 3. Wyatt wants to fence in a square portion of the yard to make a play area for his new puppy. Oh boy, puppies, I like those. The area is covered, the area covered is 2 square meters. How much fencing should Wyatt buy? Wyatt will need 4 times the square root of 2 meters of fencing. That probably does not make much sense to you. So how much fencing does he need? He has a square. Inside this square is 2 meters squared. So how long is each side? If the whole thing is 2 meters squared, how long, or if the whole thing is 2 square meters, how long are these sides? Well, we know that, to find the area, we take the side times the side. So this side times this side has to equal 2. So this side has to equal the square root of 2. And we have 1, 2, 3, 4 sides that is by build fence around. So we have square root of 2 times 4. Now, we don't know how big the square root of 2 is as the number. It's actually really hard to calculate. But square root of 2 times 4, we can estimate. We know that 1 times 1 is 1. And then we know that, so the square root of 1 is 1, and that's bigger than 1. So it's going to be bigger than 1. And we know that the square root of 3, or the square root of 4 is 2. So 2 squared is 4. So we know it's between 1 and 2. Oops, I put that little jaws facing the wrong way. We know it's bigger than 1, smaller than 2. Square root of 2 goes in there. So if we solve this equation and we solve this one, if we just pretend that the square root of 2 is 1, we just take this and we do 4, then we're replacing the square root of 2. Square root of 2 goes away, and instead we're putting in a 1. So we have 4 times 1 equals 4. Then for this one, we're doing 4 times the square root of 2, and we're taking the square root of 2 out and replacing it with a 2 equals 8. So we know that it's gonna be somewhere between these two. It's gonna be somewhere. It's gonna be bigger than 4 and smaller than 8. Now, um, but where exactly between them? Yeah, so what's the best we can do? Hmm. They want us to truncate. Okay, so there's no way to do what they want you to do without using a calculator. They want you to find the square root of 2 using a calculator. And then you're just going to chop off the decimal because square root of 2 is actually a non-rational number. So square root of 2 equals 1.4 times, so we were, and then a bunch of other numbers. But we're just going to take that 1.4 and we're going to replace it. So we're going to do 4 times 1.4 equals, and 4 times 4 is 16. 4 times 1 is 4, plus the 1 from the 16 is 5. Put the decimal back, we have 5.6. So we have around 5.6. Okay, how much fencing should he buy? He should buy around 5.6 meters. They say 6 meters, whatever. Sure, 6 meters sounds like a good number. Okay, G. Kelly needs to put trim around a circle tablecloth with a diameter of 36 inches. So she has a tablecloth that has a diameter of 36 inches. Use the equation circumference, which is, if she wants to put the trim all the way around the edges, she needs the circumference or perimeter of the circle. So circumference equals pi times 2 radius, or in this case, diameter. Which diameter is just 2 radius, is just 2 times the radius. And they want us to approximate pi to the ones, tenths, and the hundredths place. So if we just make pi equal to 3, so C equals 3, and then diameter is 36 inches. 3 times 36 is 3 times 6 is 8. 3 times, or is 18. 3 times 3 is 9, 10. 108 inches. C equals 3.1 times 36. 1 times 36 is 36. Put the 0. 3 is 108. 6 1 1 1. Then we put the decimal back in. 111.6. And finally, C equals 3.14, 36. And at this point, I need to use my calculator. 3.14 times 36 equals 113.04. 113.04. Now, I would basically just take these numbers and round up a little, round up to the next, spot. So I would, instead of buying 113, I'd buy 120 inches, because that way I have a little bit extra. But at the ones, we have 108 inches. At the tens, we have 111.6 inches. And at the 12s, we have 113.04 inches. Next page. Example number 4. The golden rectangle is found frequently in the nautilus shell. The length of the longer side divided by the length of the shorter side is equal to 1 plus the square root of 5 divided by 2. Estimate this value. First, estimate the value of the square root of 5. So, square root of 5. We know that 4, the square root of 4 is 2. And we know that 9, the square root of 9 is 3. So the square root of 5 is going to be somewhere between 2 and 3. So we can substitute those in. And it's going to be closer to the square root. It's going to be closer to 2 than to 3. It's going to be like 2.2 or something. We have 1 plus 2 divided by 2, which becomes 3 divided by 2, or 1.5. Guided practice. Number 1. Square root of 28. Well, 5 squared is 25, 6 squared, and the square root of 28 is bigger than that. 6 squared is 36. So we know it's going to be somewhere between 5 and 6, and it's going to be closer to 5. So this one is just a little bit bigger than 5. 2. Square root of 135. Square root of 121 is 11, a little bit bigger than that. Square root of 135, and square root of 144 is 12. So 135, is it closer to 1? Let's see, it is 9 from there. It's like 14 from there, so it's closer to 12. So this one, 12. Square root of 38.7. Well, square root of 36 is 6. Then square root of 38.7. And square root of 7 is 49. It's only 2 away from 30, well, 2.7 away from 36. So 6 is the closer one. 6 is our answer. The cube root of 51. Let's see. 3 times 3 times 3 is 27. It's bigger than 27. Oh, I should be putting my little 3's there. Sorry, on these ones I should be doing that because we're looking at, and the cube root of 4 is 64. Which one is this one closer to? Let's see. It's like 24 from 27, and it is 13 from that one, so it's closer to 4. So this is 3 square root of 51 square root of, or cube root of 4. So we know it's somewhere between 4, and it's closer to 4. Five cube root of 200. Well, 7 times 7 times 7 is going to be like 200. Well, 6 times 6 times 6. Let's see. What is 6 times 6 times 6? 216 or something. So 5 times 5 times 5 is 125. That is smaller than cube root of 200, and that is smaller than the cube root of 216. This one is 5. And this one is 6. Which one is it closer to? Well, it's closer to 216 than 125, so it's 6. $95. Well, cube root of 4 of so 4 times 4 times 4 is 64. This is third root of 95. And then cube root of 125. This is 4. This is 95. And this is 5. And which is it closer to? Let's see, it's 30 less than 125. And 31 more than that. So I guess it is technically closer to the 5. Okay. 7. Tobias dropped a tennis ball from a height of 60 meters. The time it takes in seconds for the ball to fall 60 feet is 0.25. Find 3 sets of approximations for the amount of time it will take. Then determine how long it will take for the ball to hit the ground. Okay, So first I'm going to approximate it by saying square root of 60 is between the square root of 7, which is 49. So square root of 7, or 7 squared, square root of 60, and 8. And it is closer to 8, but it's going to be somewhere between these two, but closer to 8. So it will take more. It will take more than 0.25 times 7, because I'm basically substituting the 60 with a 7 here, and it will take less time, so it's going to be greater than this one, and it will be less than 0.25 times 8. 0.25 times 7. Let's see, 7 times 25 is 175? Or no, 1.75? This is 1.75 seconds. And this one is 0.25 times 8, which is 2. So somewhere in between 1.75 and 2. So my first answer is between 1.75 seconds and 2. Or, then my third answer is going to be just a, using my calculator, the square root of 60. And they gave me 7.7. So I'm taking this down here, and the square root 0.25 times the square root of 60, which I am approximating as 7.7, equals 1.925. Okay, so we'll take approximately. So my first guess is between 1.7 and 2, and my second guess is around, or roughly, 1.925 seconds. These two answers I got by rounding. This one I got by just putting it into my calculator. Number 8. The number of swings back and forth of a pendulum, length L and inches each minute is 375 divided by the square root of L. How many swings will a 40-inch pendulum make each minute? So if we substitute 40 for L, and we need to get an approximate rating. So we know that 375 divided by the square root of L is going to be, we know that this is going to be bigger than 375 divided by, oh, okay. And then we are replacing L with 40. L, 40 equals L. So we know that's going to be bigger than 375 divided by the square root of 36. And we know that's going to be smaller than 375 divided by the square root of 49, which is 7. So this one equals 375 over 6. This one equals 375 over the square root of 40, because remember we're substituting that 40 in for L. And this one is 375 over 7. Six, 375 divided by 6. I can't do that one in my head. Equals 62.5 according to my calculator. And $375 divided by 7 is 53.57. So we know that this one is between those two. So we know it will swing between 62.5 and 53 times, and it's going to be closer to the 36. It's going to be closer to the 62.5 than it is to the 53.57. So it's going to be between 62.5 and 53.57 swings per minute. How can I estimate the square root of a non-perfect square? Find a perfect square close to it. Okay, 8th graders, I want you guys to do, oh, did I forget to write all the answers? I forgot to write all the answers. 1 is 5, 2 is 12, 3 is 6, 4 is 4, 5 is 6, and 7 is 5. Okay, kids. I want you guys on the independent practice. You guys are just doing the independent practice. You aren't doing the all the other review stuff. And I want you guys doing the odds on this one. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. You don't have to do the extra practice. I'll give you guys a little bit of time to get done with those. Once you're done, come back, watch the rest of the video, and we'll move on to the next lesson.